Discovering the universe beyond. What are exoplanets? Have you ever looked up at the night sky and wondered, is Earth truly unique? Or are there other planets out there harboring life just like ours? Could there be another Earth-like world orbiting a distant star waiting to be discovered? These questions have captivated humanity for centuries. Today, we dive into one of the most exciting frontiers of modern science, exoplanets. Planets that exist outside our solar system, worlds beyond the realm of what we once thought possible. But what makes these exoplanets so special? And how do scientists determine if they could support life? Let's embark on this cosmic journey together. First, let's answer the big question. What exactly is an exoplanet? Simply put, an exoplanet is any planet that orbits a star outside our solar system. In 1992, the first confirmed exoplanets were discovered. Before that, they were just a theory, something we speculated about. But today, we've identified over 5,000 exoplanets and counting. Think about that for a moment. 5,000 potential worlds. Some of them are as bizarre as your wildest science fiction stories. Gas giants that make Jupiter look like a pebble. Planets with atmospheres of molten glass. And, of course, the Holy Grail, Earth-like planets in the habitable zone. Each discovery expands our understanding of what's possible in the universe. We're not just finding new worlds, we're uncovering new rules of nature. What if some planets defy our definitions entirely? What if some orbits are black holes or exist in complete darkness? Now, you might be wondering, how do we even find these distant planets? After all, they're so far away and most don't emit light like stars. The answer lies in ingenious techniques developed by scientists. One of the most common methods is the transit method. Here's how it works. When a planet passes in front of its star, it causes a tiny dip in the star's brightness. By observing these dips, scientists can infer the planet's size, orbit, and even its atmosphere. Another fascinating method is the Radial Velocity Technique. Imagine a star and its planet locked in a cosmic dance. As the planet orbits, it tugs slightly on the star, causing it to wobble. By measuring these wobbles, we can determine the planet's mass. And then there's direct imaging. Using powerful telescopes, scientists can block out a star's light to directly capture the faint glow of its orbiting planets. This method has revealed some of the most stunning visuals of exoplanets yet. These techniques have revolutionized astronomy. They've opened a window into the vast diversity of planets in the universe. And they're constantly evolving, promising even more discoveries in the near future. So, what have we found out there? Let's explore some of the most intriguing exoplanets discovered so far. First, meet Kepler 452b. Often called Earth's cousin, this planet orbits a star similar to our Sun. It lies in the habitable zone, where temperatures might allow liquid water to exist. But here's the catch. It's 1,400 light-years away. If we ever wanted to visit, it'd take us millions of years with current technology. Then there's HD 209458b, also known as Osiris. This exoplanet is a gas giant, but it's unlike anything in our solar system. Its atmosphere is being stripped away by its star, leaving behind a trail of gas. Imagine a planet literally evaporating in space. And who could forget TRAPPIST-1? This star system hosts 7 Earth-sized planets, 3 of which are in the habitable zone. It's a treasure trove for scientists studying life's potential beyond Earth. What's fascinating is the proximity of these planets to each other. Standing on one, you might see another looming large in the sky. Then there's 55 Cancri e, a planet believed to have a surface covered in diamonds. Its extreme temperatures and high carbon content make it one of the universe's most exotic treasures. Every discovery tells a unique story. Every world adds a new chapter to our cosmic narrative. But what makes a planet habitable? It's not just about having water or the right temperature. Habitability depends on a delicate balance of factors. First, the planet must be in the habitable zone of its star. Too close and the planet is scorched. Too far and it's a frozen wasteland. But even within this zone, the situation is complex. Some planets may be tidally locked, with one side perpetually facing their star and the other in eternal darkness. Second, the planet's atmosphere plays a crucial role. It needs to be thick enough to trap heat, but not so dense that it becomes toxic. Think of Venus, with its runaway greenhouse effect, definitely not ideal for life. Then there's the planet's magnetic field. Without it, solar winds would strip away the atmosphere, leaving the surface barren. Mars, for example, is a prime example of what happens when a planet loses its magnetic shield. And finally, the star itself matters. Stars that are too active or unstable can bombard planets with deadly radiation. Stable, long-lived stars like our Sun are the best candidates for hosting life. So, could there be life on one of these exoplanets? The truth is, we don't know yet. But there are tantalizing clues that suggest we might not be alone. Take biosignatures, for instance. These are chemical signs in a planet's atmosphere that could indicate life. Oxygen, methane, and even water vapor are key markers. In fact, scientists recently detected water vapor on a planet called K2-18b. It's a super-Earth located in the habitable zone of its star. But detecting these biosignatures is no easy feat. It requires incredibly sensitive instruments like the James Webb Space Telescope. And even then, we need to be careful not to jump to conclusions. False positives are possible, as certain chemical processes can mimic the signs of life. Let's take a moment to imagine, what if we do find life on an exoplanet? Would it be microscopic, like bacteria? Or could there be intelligent civilizations looking up at their sky just as we do? And what if they've been trying to communicate with us all along? These are the questions that drive missions like SETI, the search for extraterrestrial intelligence. But here's a sobering thought. Even if life exists, the vast distances between stars might keep us forever separated. Our nearest exoplanet, Proxima Centauri b, is still 4.2 light-years away, and traveling there would take thousands of years with current technology. Yet the dream persists. The idea that one day our descendants might traverse the stars is a powerful motivator, but perhaps that's not the point. The search for exoplanets isn't just about finding life. It's about understanding our place in the universe. Are we a cosmic accident or part of a grander design? Every exoplanet we discover is a reminder of how vast and mysterious the universe is, and it challenges us to think bigger, dream further, and never stop exploring. So the next time you gaze at the stars, remember this: there are countless worlds out there waiting to be discovered. And who knows? One of them might just be a second home.